Hello, good evening. I'm going to show you how to check for outliers using Sapling's Crunchit. I apologize for the glare of my glasses. It can't be helped. But let's go to share screen and to see this. Now, the first thing to do is I would go into Sapling. And again, you're welcome to do this with another software package. But let's go into Crunchit. And you'd be entering Crunchit from the homework problem, because if you notice that the homework problem has a lot of data to it, there's a little array of things that say Crunchit. And I'll show you that at the end. But anyway, first of all, now that we're at Crunchit, let's first of all upload the file here. And the file, I'm going to upload an example that I found interesting. This is exercise 35 in the textbook. And this rates the number of nurses per 100,000 population, which of course in the time of COVID is a very interesting thing. Now you can see if there's a bunch of numbers here, and I'd like to figure out, are there any outliers in this group of numbers? So the way you do that, the very first thing you need to do is you need to figure out what the quartiles are. And statistics, let's go to statistics and let's go to descriptive statistics. We want to look at the number of nurses and let's calculate. And the first thing you realize that when it comes to the number of nurses, the first quartile is 798, the median's 901, and the third quartile is 1017. Now, the first thing you want to do is you want to calculate the interquartile range. So quartile 3 is 1017, quartile 1 is 798. So what we do is we do the calculation. The interquartile range is 1017. And I better check this again because I have a very poor memory. 1017 minus 798. I'll scoot this over. And that equals, if you just calculate that, 1017 minus 798. And I know you can do that by hand, but I'm being lazy. That's 219. Now, 1.5 times the interquartile range by our formula there, that's going to equal, well, 219 times 1.5, using my calculator, is, let's see here. Oh, I screwed that up. And I get 328.5. So, using this, our outliers, therefore, will either be below the lower quartile, Q1 minus 328.5, or above Q3 plus 328.5. So let's calculate these numbers. So the first one, Q1 minus 328.5, is, and there is a little bit to do here, 798 minus 328.5, and that is 469.5. Oops. Now let's do the other one. Quartile 3 plus 328.5 will equal, that's going to be 1017. I'll just go ahead then. Okay. Right here, 1017 plus 328.5 is equal to 1345.5. 1345.5. Make sure that's it. I can barely see. Yeah, and I should have just given you the little bit of here. This quartile 1, of course, is 798. Minus 328.5. And I'll spread this out a little bit so it doesn't. That's how you arrived at that. So those are the two numbers. So we look for numbers below or 69 and above 1345.5. So those are the two magic numbers we want to look for. So first thing we notice, the minimum is 585. So the min, so I'll go over here. Which is bigger than 469.5. So there's no low outliers. On the other hand, what about the max? Well, the max is 1483. Which is bigger than so the max is bigger than 1345.5. So there are outliers. Upper, high outliers. So which ones? So let's go here. So what we need to do is we need to find every number. Sorry about that, but we need to find every number that's above 1345.5. So going to that, let's see what they are. Oh, come on. All right, 1345.5. And the way you do that, if you see this little arrow here, well, if you hit this little arrow, you get a way to sort. So I'd like to sort going from high to low. The reason I'm going from high to low is I want to find all numbers that are above 1345.5. And the numbers that are above 1345.5, there's really only one of them. It's DC, which is 1483. So the conclusion is 1483 is the only outlier. So I'll put that in red here. 1483 for DC is the only outlier. And that is how you check for outliers. Thanks for watching.